Hello there. In this video we're going to discuss an application of the interquartile range and quartiles with respect to detecting possible outliers of a set of data. So let us assume we have our data and we can plot it all on, some real line. So let's assume it has some cluster here with a couple scattered points out here. And let's assume we have some point out here. So the question that an outlier answers is this point extremely far from the majority of the data? Like, is this distance really far or is this distance really far? So this test pretty much answers the question, how far is too far? So the interquartile range outlier test will answer this question for us. Alright, so before we get into the Iqr outlier test, let's just review a few basics on quartiles and Iqrs. So usually when we have a set of data, we usually partition it into 4 sets. Therefore, there's going to be 5 numbers that is going to create that partition. So the first number is Q0, Q1, Q2, Q3, and Q4. Q0 is typically defined to be the minimum. Q4 is typically defined to be the maximum of the data set. Between Q1 and Q0 and between Q3 and Q4, 25% of the data lies there. In between Q1 and Q3 lies 50% of the data, right? Which we usually represent by a box. And Q2 is what we usually refer to as the median. Q1 and Q3, the interquartiles. And we define the interquartile range, or IQR, to be equal to the difference between Q3 and Q1. And you can do the absolute value if you want and do Q1 minus Q3, but this should be a positive number. So depending on this distribution, we know that 50% of the data is going to lie between Q1 and Q3, and this is usually where the majority of the data is going to lie, right? So what we want to know is, okay, so let us assume that this point, this Q4 is actually way out here, like extremely out there, and like Q0 is here, right? So a question would be, is this maximum an outlier or not? Well, one way we can sort of think about it is we can sort of extend this box a little bit outwards by some distance, right? And as long as this point lies in between these two lines, then it's relatively close to the majority of the data and it's not an outlier. So the question that this test does is to find this distance, which I'm going to abbreviate by delta, to give us some threshold to sort of see whether it is or not, right? So this distance is definitely going to be based on the width of this box, right? So this interval, right, is going to be defined to be equal to Q1 minus some distance, and then Q3 plus some distance. Now this distance by this test is going to be 1.5 times the IQR, right? And this is the IQR outlier test and what it chooses to use. The IQR outlier test. Now you could choose 1.6, 1.7, 1.8, but this test chooses 1.5, right? So therefore, this interval of outlier detection is going to be Q1 minus 1.5 of the interquartile range and Q3 plus 1.5 of the interquartile range. And if you prefer 3 halves instead of 1.5, then that is perfectly fine. So how do we interpret this? Now remember, this number could be greater than the minimum, and this number could be less than the maximum. That is, these numbers could be in between the tails of our box plot and the interquartile values, right? So keep that in mind. Right, so a couple scenarios here. So if x lies within this interval, then x is likely not to be an outlier of our data set S. And if x is not an element of the interval, then X is likely to be an outlier of S. And we'll talk about this word likely later. This is associated to probability. Because just because a number is outside extremely far from these boundaries, it does not necessarily mean that that is an outlier. It could be a start of a new trend that we haven't yet had time to study in detail, right? So when you decide what you want to do with these outliers, once you do define them, definitely give some care to that value. So now that we've pretty much outlined and explained the IQR outlier test, now let us work through an example to sort of illustrate how it's used. Alright, so let's look at our example set, and let's assume it has the values 14, 19, 13, 12, 9, 11, 17, 21, 23, and 4. Alright, so take a moment and calculate the inclusive interquartiles for this data set. So once you do that, you're going to find that Q1 is going to be equal to 12.25 and Q3 is going to be equal to 20.5. So once you calculate the interquartiles, we can easily calculate the IQR to be the difference of these two. So 20.5 minus 12.25, which in this case is equal to 8.25, right? So this is the interquartile range. Right? So therefore the distance of our outlier detection interval is going to be 1.5 times the interquartile range. So this is going to be 1.5 times 8.25. So this is going to be equal to 12.375 once you calculate that out. Right? So therefore our interval for outlier detection, remember, is Q1 minus delta and Q3 plus delta. Right? So that means our interval for outlier detection is going to be equal to 12.25 minus 12.375, and then 20.5 plus 12.375, which gives us the interval negative 0.125, comma 32.875. Right? So this is our interval. So all of our numbers, so now we can test and compare this interval to our data set S. So every number that is negative or bigger than 32 is an outlier. So if we look at our data, we have 1, 45. So since 45 is not an element of this interval, that means 45 is likely to be an outlier of S by the IQR outlier test. Right? And that's pretty much how we can use the outlier test, the IQR outlier test, to determine whether a point of a set is an outlier of that test or not. Hope you enjoyed.